So unfortunately, the PXL-350, the original light pen interface, doesn't have any known drivers. Hopefully those will show up someday. But what I do have is a PXL-380. It's only a few years later, and it's supported by FTG's last driver package. So that card is right here. And I have my little light pen box. I haven't attached it to my case because obviously I wouldn't, but it would normally go through the grommet in the back of your computer and in here to the light pen header on the light pen interface card. So there's actually no light pen connected to the CGA at all. But what we do have is a splitter cable coming out here, and that comes to my makeshift sync cable. That does come in through the ISO plate, and you can't really see it, but it's down there plugged into the bottom sync header. And that's really only carrying 3 conductors. It's got the vertical sync, the horizontal sync, and ground. There is plus 5 volts outbound on the sync header. I'm not sure what that's for. I've never seen a cable that had that actually go anywhere. Maybe they were thinking about some kind of externally powered sync device. Don't know. But in any case, this is ready to go, and it does work. So let me show you that now. So I have fixed my IBM 5150, as you can see. It just had a little bit of metal shrapnel in its RAM bank 2. So we've got the PXL-380 card installed, and now we have a hard drive too. So I've loaded the light pen drivers in here. Let's take a quick look at the light pen drivers. It's kind of interesting. So when you install them from the floppy, you would run pixel setup, and I'm not going to go through the setup all over again. It basically asks you to pick your card and the IRQ, and if those are wrong, it did not detect the card. So it's good that it's detecting it. We have a number of display adapters that are supported, which is actually kind of impressive. There is a notable lack of Sing Labs, but you can see it supports even several super VGAs, even on this older card. Mousetrap was the brand name for their mouse emulation software. I haven't played that. I don't really have anything on the 5150 that needs a mouse. But maybe we can look at that later. The blue flood. So this is a thing that it does when you click on an area of the screen that is black, because normally that can't be tracked by a light pen. This will flood it with blue. And there's several methods you can use. So software blue flood, I suppose, just, well, I'm not sure exactly what it is, if it's a palette trick or if it's actually changing VRAM. You can see that one of the external light pen interfaces came with a hardware blue flood module, and we're going to use background index flood. I'm not sure what that actually does, but we're going to select blue because that's the best color for the light pen. Now, I had previously said that light pens respond best to the blue wavelength, and I have subsequently learned that that's not actually true. It's more that the light pen wants to see a peak, a well-defined peak, because it's applying a high-pass filter to the light signal that the photodiode is returning. And it just so happens that the blue phosphor has the sharpest response. There's basically 2 curves. You have the phosphor activation curve. How fast does the phosphor light up, basically? And then you also have the decay curve. How fast or how slowly does the phosphor return to black? And blue is just the fastest of both ends. So red being one of the worst, and obviously the certain P39 green phosphors were also not great. Anyway, that was a lot of words. Basically, blue is good. Just not for the reason I told you. Tracking cursor, this is an extension to the int10 subfunction for BIOS where the pen will keep reporting its position even when the switch isn't pressed. Originally, the way that the subfunction for interface is described by IBM, that would not be the case. Because you only get data returned if the switch is pressed, but this is just going to return data all the time, which is useful because you want to see a live cursor. And we have position processing. This is what happens when you press the button. Locking position continuous reports is basically what the warp speed driver does, but that's not good for paint programs. Also, we don't want a single port report if we want to paint. That's not going to be good. And normal reports would be accepted only if light is detected. And let's just leave it on normal. So accept these configurations, and let's go through the calibration just so you can see that. This is kind of interesting because I haven't seen any other light pen calibration that works quite the same way. What we're asked to do is move the pen over these lines at the border. This is basically just defining the borders of the screen, right? The edge of the overscan. So that's all we need to do to calibrate our light pen card. So we can see here that it's telling us what options. Look at the copyright date, 1996. That was my junior year in high school. But it's just crazy to think they were still making light pens. Like, I had always thought the light pen was extinct. Who knew? But notice we have no smoothing enabled. And I'm going to show you that is a bad thing. Let's start up our PC Illustrator. This is with no light pen smoothing. Wait, did that say light pen? Oh, you know what? I bet since this is on the hard drive now, it's saved my choice. Good to know. So one thing with the FTG driver is that now that we have continuous updates, you can see that we have a live little mouse cursor. Or light pen cursor, right? It's not a filthy mouse cursor. Imagine using a mouse, even if you have delicious cheese. So I've kind of got to reach around my camera here, but let me see if I can give you a good demo. This is wobbly as hell. Notice how the cursor is kind of freaking out, even though I'm not really using it. That's still a vast improvement over the CRTC-based light pen interface. But we can do much better. Let me quit out of here. I don't want my pictures and say. So we're going to go back. So we've got a lot of options in this BIOS here. If we do pixel BIOS question mark, this is a lot of stuff that we couldn't actually set and set up for some strange reason. And the main thing that we want to look at is smoothing or jitter control. So what this does is it actually just averages out like the last 0 to 15 frames of positional data so that your cursor isn't jittery and isn't shaking around so much. Obviously there's a trade-off there between smoothing and latency, right? So TGA is nominally 60 Hertz. If we even did 2-frame jitter smoothing. That takes us down to 30 hertz. 4 frames would take us down to 15 hertz. So it starts to get pretty bad. But, you know, if we draw slowly, a certain amount of smoothing shouldn't be that bad. Let's try it. Well, I've already experimented with this a bit. Let's try 7 frames of smoothing. And we see there at the bottom, multi-frame smoothing enabled, set to 7 frames. See if it remembers my light pen, if I was hallucinating that. It does remember my light pen. So, it's just barely perceptible that there's some lag there. I mean, you're not whipping this thing around. It's not like you're taking op headshots in Counter-Strike here. It's a light pen. So let's start drawing and we see if we can reproduce the smiley. And it's pretty easy to see how much better that is. Of course, I've got my arm outstretched and I'm reaching over a camera, so you'll have to excuse my lack of artistic prowess here. But this is considerably better than not using a light pen interface. If you were going to use a light pen, if you were so inclined, you absolutely had to have a light pen interface. There's just no question about it. So there's not much to say. It's still a light pen, but as you can see, the light pen interface does work, and it does make a absolutely enormous improvement in accuracy. Thanks for watching.